Prime, factorization, All right, so before we can do this, we have to know first, what is a prime number? Well, a prime number is where the only numbers that can be multiplied or divided by is 1 and itself. So guys, let's just kind of go in a list here. I'm going to skip the number 1. We'll talk about that another time. But think about the number 2. Oops. Number 2. Well, the only way that you can get 2 is to multiply 2 times 1. There are no other whole numbers that can multiply to 2. So we've got 1 and itself. So 2 is a prime number. Well, let's try the number 3. We know that 3 times 1 is obviously going to get us 3. But does anything else? No. Nothing else multiplies to get to 3. So 3 is a prime number. Well, what about the number 4? Well, we do know that 4 times 1 equals 4. But does anything else? Yes, it does. 2 times 2 also equals 4. So that is not a prime number. So if we go through the list here, and we kept doing that for everything, we would start seeing, at least for those beginning numbers, so 2, 3, 5, 7, 11, 13, 17, 19, 23. I think that's our starting list. So guys, these are all prime numbers. Nothing else can multiply or divide into these numbers besides the number 1 and their own number. So only the number 13 fits inside of 13. Only the number 19 fits inside of 19. Now, besides the number 1, of course. 1 fits inside of everything when we're talking about whole numbers. But prime factorization means that we're taking big numbers. So I'm going to use from the textbook, I'm going to use example number, oh actually it's not an example number, but it's in your textbook on page 26, the number 60. We want to get this number broken down. So let's see, we want to break it down into just prime numbers only. Well, in order to do that, we have to divide it by prime numbers. So let me list some of those out again. So we can only divide 60 by numbers that go into it. So you got to think to yourself, does the number 2 fit inside of 60? 3, 5, 7, 11? I can tell you for sure, we know that nothing times 7 gives us 60, not a whole number. Nothing times 11 gives us 60. So let's make it easy here. So let's break it up by 2. I think all of us in our heads can do that. So we have to split it up by a prime number every time. So 60 divided by 2. Let's put the prime on the left. So 60 divided by 2 gives us 30. So guys, there you have it. There's one of your prime numbers. And we know that that can't be split up any further because the only thing that goes into 2 is 1 in itself. So let's do the same thing with 30. We know that we can still split that up. Well, what are one of these prime numbers on the right that you can split up 30 by? You can choose whatever you prefer. So let's skip the number 2. We know that number 2 will fit. Let's try the number 3. 3 times what gives us 30? 10. So there's one prime number. It can't be split up any further, but we can split up the number 10. Well, let's see. What can we split that up by? Oops, what am I doing? Let's say we split that up by 5. We know that 5 goes inside of 10. Well, how many times? 2. And look at that. We're done. We're left with only prime numbers. So guys, that's it. That's prime factorization. We broke it down into just prime numbers. So 2, 3, 5, and 2. We're done. That's it. Now we just have to list them. Now we list them in order from least to greatest. So we've got the number 2, and this is how we list it by multiplication. I'll show you why. 2 times, well, there's another 2, 2, 3, and 5. And now you have it. You did a factor tree. That's what we call this. It kind of looks like a tree that we're branching down. And you found and did your prime factorization. And guys, if we worked this out, you would start seeing, you would say 2 times 2 is 4. 4 times 3 is 16. And 16 times 5 gives us 60. That's the number we start off with. You don't have to worry about that part right here as long as we show this. There's your prime factorization. You found all of your prime numbers. Well, now let's do example 3 on page 27. This one's actually a pretty big number. So we've got 1,575. I'm going to go ahead and erase this and put that off to the left side. All right, and I did that because I want to have some side work. Miss Harrison loves her some side work. All right, I'm also, again, going to list some of those first set of prime numbers so that it helps me split this up. Now here's an example where, because 1,575 is kind of a big number, we don't have to always start off by dividing by a prime number. Maybe you just want to break this up into a couple of smaller numbers. So guys, here's what I like to do. I like to think about money. Because this ends in 75, I like to think about 75 cents. And because those are the last digits. Well, when it comes to money, I think about quarters. Quarters are worth 25 cents. So I know that a quarter can help make 75 cents. So I want to break this down. When I break down, I do what kind of math operation? I'm doing division. I'm trying to split it up, make it a little bit smaller. So I know for sure, because it ends in 75, I can divide it by the number 25. It's not a prime number, so I'm not going to circle it because it is not a prime number. But I'm going to do some division. I'm going to do 1,575 divided by 25. Because whatever number is the answer, that's what's going to go here. Because those two numbers are going to multiply to get 1,575. All right, let's do this. Dead monkeys smell bad. 25 doesn't fit into 1. It doesn't fit into 15. But it does fit into 157. And guys, this is the nice thing about 25. Again, think about money. Instead of 157, think about it like $1.57. So how many quarters would it take to get you close to $1.57? Well, 4 quarters make $1. So there's my 4. And then 2 quarters make 50 cents. So guys, that's it. 6. So 25 fits into 157. Oops. 6 times. Now I could do the work off to the side. 25 times 6. 30, 12, 13, 14, 15 gives us 150. So 150 is close to 157. So here we've got it. 150, subtract, and bring down. And again, think about money. How many quarters does it take to make 75 cents? 3. And we can do our side work just to show, just in case. 25 times 3. That gives us 15, 6, 7, 75. Perfect. So 3 times 25 is 75. We're done. We got a 0. There's nothing left to bring down. So 25 and 63. So here we've got 25 and 63. So again, I'm not going to circle anything. We're back to the left side now. I'm not going to circle anything because all I did was break it down. I didn't split it up into prime numbers. I'm just trying to make them smaller numbers that we can easily see what might multiply together to get them. So let's make it easy here. Let's start with the 25. We're lucky with this one because, guys, what number makes up 25? I'm going to repeat that easily. 5 does. So we know that 25 splits up into 5, and 5 times what gives us 25? 5. But guys, those are both prime numbers. I can't break them down any further. So I'm going to circle both of them, and I'm done on that left side. There's nothing else that I can do. But the number 63. What two numbers can multiply together to get 63? But one of them has to be a prime. Now this one does require us knowing our multiplication tables to make this easier for us. But just to jump ahead so we get to it, the number 7. So 7 and 9 multiply together to get us 63. All right, 7 is a prime number. I can't break that one down any further, but I can break up 9. So what breaks up? That's a prime number. That helps me get 9. 3. 3 and 3, which again are both prime numbers. So guys, now I'm done. List them from least to greatest, left to right. So 3, 3, 5, 5, and 7. And guys, if we do the work, and I'm just going to pull up my calculator so that we can show this quickly. 3 times 3 is 9. 9 times 5 is 40. 40 times 5 is 200. And 200 times 7. Oh my goodness, hopefully you guys were keeping up with me and realized that Miss Harrison made a boo-boo. I'll start that over. So 3 times 3 is 9. 9 times 5 is 45. 45 times 5, 225. And 225 times 7 should give us our final of 1,575. And guys, the final answers that we were looking for, all that we were looking for was this: 3, 3, 5, 5, and 7. Now guys, I am not going to give you a question where your number is this big. I just want to show you guys some examples of how you would do this with big numbers. So let's say all you had to do was do the prime factors of 25 and then the prime factor of 63. Well, you would still get the exact same numbers. We just broke it down to the 25 and 63 first.